start our lecture. Today is December 7th, so Thursday. So it's week 14. Week 14, we'll talk about unit. So we have catch up with the lecture. So we'll talk about unit. And next week, we'll talk about the first and the mask RCNN. So we already teach you about from the net and AXNet. This is for the beginning. And then we talk about VGG and GoogleNet. Last week, we tell you about the ResNet. So those are encoded, and today we are talking about the UNet. The first 2 hours we are talking about UNet, and the third hour we will give you the lecture, the homework, the second homework. So before I teach you the UNet, I would like to, based on this one, the history. So that's what I mentioned. In 1998, we have the net here. So there's the net we call the net 5. So 2 convolution plus 3 neural network. That's the net 5. And in the important one is a VGG. But before that, we have an AXNet in year 2012. And AXNet has a 5 convolution plus 3 neural network for classification. So the same as the net, they use the 3 fully connectional layers for classification. But both are not good enough. So the better one is the VGG. So, but the same as this one, VGG, they have a 5, but it's not 5 layers, it's 5 downsamplings. So after VGG, off layer here. Wait for me. Check. Back to here. So even VGG or ResNet or GoogleNet, they all have 5 downsamplings. But this one is for classification. We call backbone. So the backbone, or called backbone encoder, is for the extraction and the classification. But if we want to detect the object, this cannot. This just you should input the object, crop object, and then do classification. But if we want to input the entire image, so we want to not only we want to do the detection, but also try to classify based on the detected bounding box. We should use first RCNN, and R is called region CNN. And it's from the Microsoft and the year 2015. But for the segmentation, this is bounding box. Bounding box, the precision is not so high because it's just a box. But if you want to segment the target, we will use we call mask RCNN. And for the detection is one kind of classification. It's 1 to 2, either foreground or background. So it's 1 to 2 classification. For classification is 1 to many. So for example, you can detect the 80 objects. By each object, you can detect the position. And then each object you can do classification to 1 of 80. Okay, so classification is 1 to many. Detection is 1 to 2. But for mask is you want to extract the boundary, extract the target. So different from the classification is the same, but the different from the bounding box is the bounding box is just a box. It's a region. And box is what? It's the center and the width and the height. So there are 4 parameters. So that's need to be use the continuum, like the mean square error, to approximate the result. But also they have a confidence value for each bounding box. And the confidence value for each bounding box is for the foreground and background. So it's a detection. For the mask, it's each pixel you need to do classification to be foreground or background. So it's classification. So it's discrete. So two are different. This bounding box is continuum. So we use the mean square error. The mask is each pixel. We want to do the classify to the foreground pixel or background pixel. So it's discrete. And after you detect the target, you can also do the classification. For the difficulty, mask is a little bit difficult because the precision is not so high for each pixel. It's pixel-wise. And so after we have a raster or mask, we need to do the downsampling and upsampling to the original resolution in order to do the detection. So that's why later on we have a retina and YOLO V1, V2, V3. And retina is better than YOLO V1, V2, V3. One important one for retina is focal loss. They modify the loss, close entropy loss, and to be we call focal loss. That's a very good one. And later on, YOLO V4 combine the advantage of YOLO V3 and the retina become the YOLO V4 and later on. And here, sorry, I forgot. For the mask, today I would like to introduce this UNet. UNet is better than mask RCNN, but first RCNN and mask RCNN is both are fundamental network. So when you want to learn the detection classification, it's better to learn first RCNN because they have a lot of story insights and mask RCNN. And today I'll teach you UNet. It's very powerful. Like a VGG is very powerful. ResNet is very powerful. So it doesn't mean you should learn sometimes you want to just because this is a lecture. So the fundamental network is very important. 就基本的 network 很重要。我们是在教书嘛，不是后面。那因为这些都是最基本的东西，所以我们要教你这些基本功，因为后面都是从这里发展出来的。So based on this kind of encoder decoder, we have a RNN recurrent. We have a LSTM, and right now we have a TCN. It's easy one and better result than LSTM. And we have a VG again. It's the same. We have encoder decoder, and we have reinforced learning. So I continue to talk about this one. So I organize this one for you. I will update this lecture on our FTP side. So original, we are do classification, just input the image. And we do flatten. So suppose image is 32 by 32. We do the flatten because this is a MLP. It's a neural network. We use the backpropagation. So each node has activation function. But before, people use sigmoid. Right now, probably people use a ReLU because it's deep. Okay. And then we have 3 layers. In this example, we try to classify digits from 0 to 9. So each time you input this one, there's an image 32 by 32, and then you label one to be 1, others are 0. But here I told you for the classification, actually this is not good. We want to recognize, classify 10 digits, for example. Your classification is better has 10 plus 1 classes. The one more classes is for the noise, for the error turn. 就是你如果要分10，例如要分10笔资料，最好输出要加1笔，这一笔是让杂讯的，因为 because sometimes your input probably is not what you need. So in that case, at least it can classify to the other classes, the other class. Sorry. So it's better to have one more class. Okay. And for the we call negative. We have 10 positive, 1 negative. So we'll put those information to the negative one. It's very important. So because this one is original, we call raw image. So even in this field, if I can extract the more information and then I input the same neural network, will the result better? So the idea is that way. So the net, he proved, he said, okay, and then if I do the input original one, and I do the filter, like the edge detection, he extract the information. So they use 6 filters to create 6 feature maps, and then downsampling, and then create 16 feature maps, and downsampling. The purpose for downsampling is what? My exam will ask you this kind of question. So you should have a selection. I will ask you why they need to do the downsampling. What's the purpose for maximum pooling by stripe 2 for downsampling? 2 purposes. Okay? One is they hope the reception field can be wider, 视野变大嘛, more global. The second is try to reduce the parameters of deep learning network. So 2 purposes. So after you have a 16 feature map and you do input here, so because you have more information extracted, we call extracted information, and then you put the same neural network, and the result is much better. So they find the extraction is very important. That's called convolution. So we call convolutional neural network, CNN. And this one is a neural network, and this is a convolutional neural network. Okay. And the same, there's loss function here, there's the other loss function here. And this is the other issue, the same one, both are the same. It's 2 plus 3, so it's the same, 2 plus 3, and you got output. And the other important one is activation getting important, activation function. So original here, probably each one, the activation function is a sigmoid. This one is very, should be careful. In the neural network, for each node has an activation function. Okay. And convolutional neural network is a neural network. So for each node has inside here. So we have a convolution, batch generation, and activation function. We have this one. But for the net, as I remember, they don't have a batch normalization because it's not deep. It's not deep enough. So the other way, if the exam, I will ask you, what's the purpose for batch normalization. What's the purpose for batch normalization? And I teach you the purpose for batch normalization. Because it will divide it by subtraction with the mean value of each batch divided by standard deviation. So normalize to be 0 and minus 1 and 1. So it will not delete some information. This is a thing, I don't remember, probably I don't have it here. The other lecture, I teach you about this. I think this one has this. So the important one for batch normalization is this one. Without normalization, some information you will lose. If you have a normalization, okay, you can concentrate the information and input here. Okay. So one way is that you don't lose the information. The other way is that you can, because they have a vanish problems, you do the back propagation, and each time you do the relative waveform, your information becomes zero. So after you normalize, so before you become 0, you will normalize to 0 and 1 or minus 1 and 1. So the information won't be loose, won't be vanish， 就是你不会，因为你是微分以后那个值都越来越小，对，接近0，那就没了，就你都够 deep 的话就没了。Because if you are deeper after you do a lot of gradient descent, and then your result will become 0. It's not good. So batch normalization become very important for deeper neural network. Try to, first of all, we want to keep the information the same. So because we keep the information, so we will avoid the vanish problems. Vanish problems caused by gradient descent derivative. And the third one is this one. 2, and third one is this one. You normalize, right? So it will be stable, like this one. If you don't normalize your gradient descent, it will go on the higher slope and go slowly in the other direction. That's not good because each time your dimension is not equal. So after you do normalization, you have an equal for each unit of the weight is the same. So your gradient descent will be faster, will be stable. 3. The first 2 is almost the same. First 2 is what I say is that you try to keep your value, and also you try to, because of that, and you can avoid the gradient descent problem, the vanish problems. The second is you want to, because you have an equal unit vector. So when you do the derivative, and you will be more stable, more faster. And then gradient descent, because normalization is important. So we have a batch normalization here. A batch normalization, one important one is if each batch, your data is too small, of course, will cause bias problems. Bias is meaning because you do the mean standard deviation, but if your data is small, like only 4 images for each batch, 8 images, 16 probably is fine, is okay. 8 is dangerous. So suppose you have 4 or 8 images for each batch, and then because your mean for each mini batch are so different, standard deviations are different. So even though you do the mean, you do the standard deviation normalization, you're biased. So we want the batch for each image size or batch size for mini batch should be large. So what they can do is they do the group. They do group normalization. So they consider the channel number because you do the downsampling. So your result is more channel. You have a 3 channel in the beginning, and then probably 32, 64, 128. So you more information. So you consider the channel. So that's meaning for each small group, your data is enough to do the mean and standard deviation. So either way, the group normalization will reduce the small mini batch problems. And between here, there will no layer normalization, and instant normalization is getting important for each pixel. If you research, you will find the pixel is important. For example, you do segmentation. That's what I just tried to teach you. The unit. Each pixel is important. Then you do the super resolution. Each pixel is important, and then probably you will use instance normalization to enhance each pixel. So back to here. So as I know, in the LINNET 5, they don't have batch normalization, as I remember. So later on, you can put convolution, batch normalization, and activation together in this order. But sometimes, as I told you, sometimes convolution, activation function, and batch normalization sometimes do this one. So this for the classification. And then the field is from there, this one, we have 2 plus 3 is not deep enough. So later on, VGG has a 16. So we have a 13 convolution plus 3 classification. So this is a VGG. It's very powerful. So the red one is a maximum pooling for downsampling. And we won't count it to be a layer. We won't count the maximum pooling for downsampling to be a 1 layer. No, because it's not convolution. So convolution is this one. So we have 13 convolution layers here. And after here, we have a neural network. So the same. Okay. And the same VGG, after VGG, like for example, 16, the initial layer is for the local information. The later on will be global information. Okay. And the other one, why we need to do the downsampling is here, right? We do it here, downsampling. And the same filter size, 3 by 3. So after you do the downsampling, your reception field become wider because your image resolution becomes smaller. So we consider in a higher resolution level, we consider the detailed local information. In the lower resolution, we consider is global information. So the other question, if I ask you, global information actually is a geometric information. Geometric is meaning like our face, we will find out our eyebrow is above the top of the face, mouth is the bottom of the face. That's geometric information. But what is the difference if I ask you? Because the GPT, the transformer, as I already teach you, GPT transformer has 2 advantages. One is that they have a position information. The second is a self-attention. Two important one for GPT. compare transformer and the CNN. Transformer is a position information, have a self-attention information, enhance attention. Attention meaning the important feature, they do the weighting, do the enhancement. Back to here. So Professor just said, this is a wider field, right? They consider global information. Transformer have a position information. So what's the difference? The difference is that in CNN, they only use a filter, and then they consider this local, right? And the global information. Global information we also call geometric information. But here, we just give him the image. So computer just know, okay, they have an image, and this image, for example, this we call recession field. They have eyebrows here, nose here, mouth here. But they don't, the computer doesn't really know this position important. This is not label, this kind of image. We don't tell computer, we don't tell neural network say, oh, the position here, and the other position here, and this distance, we did not tell. We did not tell the distance. And we did not tell we have a left-hand side eyes, right-hand side eyes. You just tell, okay, there's an image. So when you do the comparison, you just try to find the similar image, but we don't enhance the position. But for the transformer, for each position, we are giving the index, position index. So for example, in the image, our face is here. So suppose this index here, we give the position. The center of this eyebrow is 100, 100. The center of this eyebrows, the x is 100. Sorry, x is 150, and y is 100. So this 100, 100 position. This 150 and 100 xy position. And the mouse, suppose the corner is on top of here, so the mouse probably 200 in right, sorry, 100, 150, so probably middle, so 125, and the y probably is 200. We give the position information to the transformer. That's difference. CNN, we don't give the position information. Transformer, we give the position information. So the first difference for the transformer. And second is self-attention, we'll talk about later. The other one is I will ask you for the second exam, we'll have a postpone 1 more week for the second exam. I will give you. 就第二次考试 today we'll give you the assignment, and the exam is originally is week 16, but we'll postpone 1 week. So the second exam will be week 17. 17周我们考试 17, and final project is 18. So back to here, and the other node is, for each node is meaning what? It meaning like an eigenvector, it's meaning 1 dimension. If a 2 node is 2 dimension, 3 node or 3 feature maps is 3 dimension. So original 3 channel RGB 3 dimension, and then even 32 feature maps is meaning you have 32 dimension. So your space become higher. So each point in RGB is in 3D for RGB sample pixel. After you do the feature map, suppose 32 feature maps, is meaning each pixel you are in the 32 dimension space. So like this example, it's important. So we can do, after we do the extraction, and later we use the neural network here to classification in higher dimension. So the same here. We have a 16 feature map. It's meaning each point is in 16 dimension, high dimension, and you do classification. You use VGG here. Okay, and here probably 10, 24 dimensions, 10, 24 feature maps, the higher dimension, very high dimension. And then you do the classification. So your classification, your decision, the result is good. Back to here. So far we talk about VGG. So this we call convolution. Also we call encoder. Also we call backbone. Here, this one we call backbone. We call encoder. We call convolution. The same. But this one is only for classification. If we want to do the detection, if we want to do the bounding box, we need to do the decoder. Sorry, this encoder is decoder to recover this small page, small feature maps to original size of image in order to do the bounding box and do the classification. Okay, so this is the second part is this one. If we want to do the detection, classification, we need to do the same. This is a VGG. The same is VGG, so we just mirror this VGG. 映射过来，对称。So we have encoder and decoder, or convolution and deconvolution. So that's this one. So today I will teach you unit is this one. So this one will include the detection, will include the GAN. So I will include the GPT. So I'll teach you this one. Include the RCNN, will include the GAN will include the GPT. So we continue. And here there's two issues here. One issue is if you do the here fully connection, that's meaning you fix the size, you have problems. Your input image size is fixed. So how can we solve these problems? We will change the fully connection to be fully convolution. That's unit. Unit use fully convolutional. That's field. And this kind, many paper use VGG or ResNet here, and then do the deconvolution. Here they do fully connectional. This I cannot say this is not good. Just some people use this one. It works. So the problem is you cannot change the input image size. So the same. The other question. If I ask you, if I want, this is this one, right? So if I want to have any size of the input image, one solution is I should change this one to be fully convolutional. That's one solution. The second solution here, I keep this one. How can I change it? We use SPP. I did not teach you SPP. But SPP can solve these problems. You just write down SPP. I won't teach you this one because I don't have time. But SPP can solve these problems. So if you put the SPP module here, and you can input any size of image. Here, right here, SPP. One is the convolution, the other is SPP. You just Google, they'll tell you SPP. And continue. And this kind of network, we also call autoencoder for GAN, G-A-N, for GAN. Autoencoder, the same. It's called autoencoder. And sometimes people draw this way, this one. This one is the same as this one. So this backbone for the encoder. Here, we call NIC. Decoder, we also call NIC. And then the output loss function, we call head. And this is important. So for each deadening or GPT, we have a backbone, we have a NIC, we have a head. So the paper, when you study the paper, each paper, they have some contribution. So you think about this paper, what's his contribution? His contribution is a backbone or neck or head, either one. 就是通常会只做一个贡献而已，一个贡献就不得了了。所以你要看 paper 的时候，你要去想一下，这篇 paper 到底主要贡献是在哪一块？太多贡献就是我常跟学生讲，太多重点就没重点，那就不是好 paper。所以这里有，那这里，那 head is related to loss function, related to loss function. So head actually is a loss function. So this is so both are the topology we call topology， 就它结构 encoder decoder 结构。那如果你没有做分类，没有不需要侦测，就那个就没有这样子，那就 loss function 这样。这个最基本架构你要知道。loss function 这里有，所以 loss function 有 two kind of loss function. One is a mean square error, is a continuum. The second is discrete. So if you only do classification, you only have a backbone and head. You don't have a neck. Because you don't need to do a decoder for classification. If you want to do detection or segmentation, you have backbone, neck, and head. And head will include bounding box and classification. So bounding box is a regression, so it's a continuum. Continuum is a mean square error. Classification is discrete, so we use cross entropy. So today I'll teach you is a UNet. So what is the difference between UNet and this one? VGG. The difference is the major difference is we have a connection here. We call skip, SKIP, skip connection, or we call shortcut, 就直接 shortcut 过来。So today I'll teach you this one. So here the same. This just draw difference. This why I call UNet is because it's U. But this one actually is the same as this one. The encoder, decoder. So we have shortcut here. Skip connection here. If I do connection from here to the other one, so it's the same. So UNet 没有什么，它只是标新立异讲，我叫 UNet， 只是跟你讲，它长得像 U， 可是这个 UNet 你不要被它骗了，这个 UNet 事实上就等于这个一模一样，那就等于这里把它连过来，一样的把它连。你看这里哦 ，UNet 它是在当这里啊，当 sampling 这个我待会讲 ，this down sampling here before down sampling shortcut. Before down sampling, they do shortcut. So that's meaning, 只要考试叫你连 shortcut， 实际上是在红色down sampling之前， 解析度还没有变之前，因为 extraction 完了，我这一层 extraction 完了以后，这 block extraction 完，我把它 shortcut 过来，就是那这个如果有 shortcut 的画法，跟这个画法跟这个画法是一模一样的，也是一样的东西，只是 Unet 它出这篇 paper 的时候，它比较标新立异，跟人家不一样，就把它称为 Unet。他成功了，因为他很有名。So this is very powerful one，这很有用哦，很强哦，不是不强，很强。所以我再回到这边几个重点 ：BGG is good，ResNet is good，Raster、Mask are good，Unet are good. What I mean good is meaning you can continue to revise, and it's simple and easy to revise this network. Now, YOLO is good to just apply. It's not easy to modify. YOLO 很难 modify 这样子。那我问你一个，那你能不能把那 Unet 跟 YOLO V4不一样在哪？我如果用 Unet 可以做出 YOLO V4的东西，那我干嘛用 YOLO V4？那两个不一样在哪边？就你们现在在讲，我大概会叫你 Unet。那 so both the difference between Unet and YOLO V4, we back to here. 就是我这样讲，那不一样在哪里？就用这个来讲。那当然是 Unet 是做 segmentation，我 segmentation 可以改成那个 bounding box 啊，就 head 可以改啊。那 YOLO V4的 head 它没改，它用 YOLO V3，YOLO V3 是用 Retina 的，所以用那个之前的，所以它重点不在 loss function 啊。So YOLO series they are not the important one is not loss function. They just apply somebody's loss function. So if I use Unet construction and I can change the head. So Unet I will teach you later. I don't want to do segmentation. I want to use Unet topology, but apply to the bounding box. But it's fine. Why not? Why not? Why it need to be the segmentation, right? So you change here. OK. 那 YOLO 在之后教你，那 YOLO 它也不这个不是它的，因为 YOLO 这个是用那个 PNet 也是别人的 PNet YOLO， 所以他用别人的，这个用别人的，这个用别人的，它主要贡献是在这里 YOLO V4 they have its own backbone. YOLO V4 has its own backbone here. 那我这以后再讲。So back to here. So today I'll teach you this one. Unet. 那就这个图的这里。这样，我实际上画这个图让你比较了解啊，了解我想讲什么这样子。所以稍微复习一下。那这个我讲过了，你再看，就是 loss function head here. Head is important. So I change the loss function. So I have a regression term. Lagrange term here. Why need this one? Because it has a constraint. So we want our target is either this result or this result. Why I want to teach you this one? Because GPT. Because of GPT. GPT has good result in this part. They have a constraint term here. So this constraint, the GPT, this again. So what's the difference from GAN and this one? We call autoencoder. And before I teach you GPT, because GPT have a transformer pre-trained, right? And GAN, generative is again. So what's the generative? what's a GPT purpose? And before I teach you GPT, our next lecture I'll teach you GPT, and we should understand what's a gain. So what's the difference from this one and this one? The difference is easy. This is encoder, this is decoder. This is a decoder and encoder. So decoder, you want to generate a result, so decoder become generator. And encoder is for classification, so the encoder is a discriminator. So let's say 这是画法，你看这画法跟这画只把这两个拆开，把它移过来，因为这是 encoder， 这是 decoder， 那就变成 gain 在这里。那 gain 这我后面会慢慢讲这个。那所以 gain 简单就是你有个那个是叫它这么 latent code， 那你把它产生这个图。So what's the purpose for the discriminator? What's the purpose for discriminator? In this case, this kind of a constraint. In this case, the gain is generated, but you want your result. You don't want your result have a diverse. 你不希望你的 result 是发散出去，你本来产生一个人脸，漂亮的人脸，变成一个狗脸，对啊，变成狗去了，对不对？为了不要让它一样，那就做 constraint， 要做一个 constraint。所以 discriminator is for constraint. So you want your result become this one, and this one, this one. Generator, you have a generator. You want result is this one, but this result you compare with this is the ground truth. So you want your result here, it's become ground truth, but you want your result to compete and still can discriminate. This is a one phase, it's a fake, it's zero. You want your result become the real data, is for generator, but you want your result still can separate, can discriminate to be face and fake, so 1 0， 这是矛盾的。那矛盾就是它就做一个 constraint， 让你的结果更好。这是 idea。所以 GPT 的 idea is G. The idea for the G is what? Constraint. What's a constraint? It's this one. 你希望你的结果加一个 constraint， 让你的结果更好。这是 GPT 的用意。我把这个讲完。所以最后我再举个最后例子。好，那 in my lab, we want to do this result. 我们做这个2D predict 3D 的东西。So we have a 2D image. We want to predict 3D joint. So we have 2D. Based on the transformer to the prediction, we want to get a 3D result. But we have a ground truth here. Sorry, here what I would like to say is that this is for the training. Training is have a generator and a discriminator. But for the inference, we just delete this one. We don't discriminator. We just input a random code, we call latent, and we generate the result. So this idea is for the GPT from the gain. In the inference, we don't need a discriminator. The same here. For the GPT, we have a 2D image. We use transformer to create 3D results. And we have a ground truth from the Vicom. Because transformer has a 0.1 billion parameters at least. Transformer 通常有以亿为单位的，在后面会讲为什么它以亿为单位的参数。哇，这么多，那你只要做 pre-train. I will ask you questions. What's the purpose for pre-train? Pre-train 的物理意义是什么？ What's the physical meaning for the pre-train? 那 pretrain 的意义就是你要让你的good initial result。因为我们在做 gradient descent 的时候 ，why pretrain is important? Because when we do the gradient descent, the initial position is very important. When you do the pretrain, this is we want to use stochastic gradient descent. The initial position is very important. If we have a right initial position, your convergence will be fast. Your result, the accuracy will be high because it's gradient descent. Gradient descent is not a good optimization method. No, it's not a good one. So how can you improve to get a better result using gradient descent? The initial position is very important. So pre-train is a good method to make sure it has an good initial position. So if you have a good initial position, your convergence will be fast. Your result, the accuracy will be high. Your result will be global minima, not local minima. If you have good initial position, so we need pre-train. That's pre-train purpose. So back to here. So I already teach you GPT before I teach you unit. So this one, back to here. So because we have a 0.1 billion parameters here, so we need the pre-train have to let them have a good initial value for all parameters. So that's meaning we have a good initial position for training. And we want our result. This is so this way is this one. So this is the same. Both are the same. So originally we have a transformer here. And because we need to pre-train, so we have some data, pre-train data, so we go this way. We go this way. Originally this one without pre-train. If we have a pre-train, we'll go this way. But it's not good enough because we want the result have some constraint because we want this term have a constraint. So we use the GAN. That's meaning we want our input data is 2D. We have during the training, we just put one GAN here, GAN, they have a result here, generator here. So we input become the encoder, latent code, and we do the decoder, create the same as the input. So during the training, we have a pre-train first. We have transformer. We have one more constraint term here. So the result is good. So that's GPT. So during the inference, we delete this one. We don't need this one. We just input here, transformer, and got a result. So for the inference, only this red arrow, just input here, based on the encoder network, and based on the transformer, and we got a result here. So this is so this one is a transformer, and this one is this one. 你的 GPT 的 network 基本上就是这个 network。那我当然可以把这个改成 convolution， 就这个 network， 只是中间这里用 transformer。然后呢，刚刚讲的，你这里就在 training 的时候，你这里是加一个，你先做 pre-train 嘛，然后再加一个 generator 出来，让你输入的结果加一个多一个 loss 在这边。就除了不只产生新的结果，你还产生原来的结果，把它恢复回来当 constraint。这是 training。那测试的时候，我就把 这个上面这一层拿掉，只剩下这里。所以你输出就是你的 predict 的结果。这是 GPT， 就这一条线。Okay, so we take a break 10 minutes, and then I will teach you unit. 现在是几分了？7、8、6分，好，所以我们休息到16分，6、7、6分，我们到16分继续。